Okay, hello everyone and welcome to today's webinar. Thank you for joining us. Today's webinar is Remote Sensing Solutions for Utilities and Critical Infrastructures. We're excited to share with you the latest developments to leverage imagery to automate asset management and planning. So let's get started. My name is James Slater. I'm the EMEA Channel Manager at L3Harris Geospatial. I'll be the moderator on today's webinar. I'm excited to be joined by Nikolai Holzer, Sales Engineer at L3Harris. Nikolai and I work closely in collaboration with our customers and partners throughout Europe, Middle East and Africa to deliver geospatial solutions optimized for our customers' needs. So whereas I have the day-to-day oversight on the business, Nikolai really provides the specialist technical pre-sales and engineering support to our business. We both have a strong background in geospatial, my own within GIS and remote sensing, holding a BSc from Kingston University. Nikolai holding an engineering degree in cartography from the Dresden University of Technology. So just a couple of housekeeping items before we get started. I've muted the phone lines for all attendees. So if you have any questions at any point during the webinar, feel free to enter them into the chat box and we'll try to answer these at the end of the presentation. I also need to let you know that we're recording today's session. Okay, if we can go to the next slide, Nikolai. So briefly, on your screens now, here's the agenda. You can read through this. We've scheduled just an hour for today's webinar, so I expect that we'll move quite quickly to cover everything that we want to show you. Okay, next slide, please, Nikolai. Okay, so before we get into the solution detail, I want to say a few words on L3Harris, really for those of you seeing us for the first time. So L3Harris is really a mid-size US defense technology contractor. We specialize in delivering end-to-end solutions to meet our customers' mission critical needs. We're split into 4 segments, and the part of the business speaking to you today, L3Harris Geospatial, rolls up under the Space and Airborne Systems section of the business. And really, it's here that we're mandated to provide and extract meaningful information from all types of remotely sensed data, including SAR, lidar, and optical, both from spaceborne and airborne systems. We apply our expertise to deliver transformational decision-making capabilities for end users in defense, agriculture, transportation, and of course, utilities markets. Next slide, please. So by way as a bit more of an introduction to what we're talking about today, we really feel that remote sensing technology now is combined with geospatial analytics, it's providing a really safe and accurate and a low-cost approach to automating operations that can provide critical insights faster and more affordably than traditional inspection techniques. And after years of success in the defense and intelligence domain, L3Harris has now commercialized its advanced end-to-end solutions that collect, manage, and leverage remotely sensed imagery to make informed decisions for utilities. So a few examples of these include L3Harris's deep learning technology for imagery-based asset detection, location improvement technologies, inventory as-built updates and inspection automation, lidar-based vegetation management and risk mitigation, optical-based macro scale vegetation monitoring, and also SAR-based land displacement monitoring. And we'll show examples of this throughout today's webinar. Next slide, please, Nikolai. So our history of really delivering flawless execution on some of the world's most demanding space defense and security programs for customers including US Department of Defense, NASA, NOAA and the NGA, amongst others, coupled to our class-leading position in image science for our commercial off-the-shelf technology, really enables us to bring to market bespoke solution iterations tailored for specific customer needs. We do this robustly, seamlessly, and in a way that gives our customers a high level of control over the application execution. Finally, we recognize the imperative to deliver full project lifecycle value and bring our consulting teams expertise to bear, in all cases, to exceed our customers' expectations. So that really provides the introduction that I wanted to give. I'm now going to turn the presentation over to Nikolai Holzer to get into the detail.
Thank you, James, for the introduction. My name is Nikolai Holzer, and as James already introduced me, I'm a sales engineer at L3Harris Geospatial. Thank you all for joining. Yeah, and I will now be happy to speak more about nowadays, as part of that chapter, about nowadays challenges and drivers that we have in operative asset management and utilities, and yeah, also how remote sensing data and analytics can help here to optimize costs, to increase efficiency, improve safety, and maintain reliability. So when we are looking at the challenges and drivers in utilities, and also with the ever-tightening margins, there's a need to optimize operational infrastructure management, so that the need to optimize that increases. And you see here some of the challenges in that figure that we summarized. And there's also an explosion in sensor availability, modality, and accuracy, and this providing more and more information than ever before. And with the amount of available data that, let's say, is maybe roughly doubling in maybe every 5 years, there's an ever-increasing need to manage the data and to leverage the information in it. So the challenge is less in the availability in the data, but it's particularly becoming in managing and processing the data. Yeah, here cloud architectures can deliver at scale, along with deep learning analytics that can deliver repeatable accuracy, such as for applications as classification, object detection, and so on. Yeah, and as utilities seek to improve on these aspects of network asset management, automating operations using remote sensing technology and along with geospatial analytics, this is becoming a safe, accurate, and a low-cost approach. This can be in terms of managing vegetation, monitoring assets, or also responding to a weather event. Here, remotely sensed data can provide the insights faster and also more affordably than traditional inspection methods. So the challenge of managing a network is not limited to maintaining reliability, but it also includes managing costs, improving safety, and ensuring the customer satisfaction, as we summarized it in that second table here. Yeah, and let me now show you some use cases where using and leveraging remotely sensed data can help you. Maybe one of the most important fields where remotely sensed data can help is to optimize operational asset management. Here, in the automatic detection of asset components that can help to create or, if available, to update existing asset databases. And then that often comes along with the conflation of data. Yeah. What is conflation of geospatial data? Well, it means to accurately merge 2 or more overlapping data sets which are of the same type, and this typically implies updating alignment conflicts and transferring metadata. Yeah, it's particularly important to have an accurate understanding of what type of components assets are composed of. To have, for instance, information of their age, which is maybe the most important information, and also of the current condition. And this is particularly important for predictive modeling simulations. At the end of the life cycle, the risk of failure dramatically increases, and if the components are not replaced, this can put an unpredictable risk to the infrastructure, an increase in probability of failure with probably severe consequences. Main challenges here: creating and also maintaining an accurate asset database, and the challenge in merging the databases and merging the data. Yeah, and here remotely sensed data collects either via helicopter or UAV or from other platforms. This can help to identify the current asset configurations, and here machine learning, deep learning can help. This reduces the costs by having a better set register, increases the reliability by understanding the current state of network infrastructure. Following asset detection, which means to identify the structures in an image and the components in these structures, is here the second use case is the automatic asset inspection to detect damages and anomalies. So this means to identify the conditions of the components assets are composed of. Yeah, many inspections nowadays are still performed only visually, either via helicopter or with inspectors on the ground, and this is pretty costly. Automated analysis of remote sensing data collection, and this is here really depending on what sensors are, for instance, mounted on a helicopter, on a drone. This can be lidar, imagery, also thermal imagery, infrared imagery. There are also corona cameras available. And this can help to automate blend, unblend inspections and deliver accurate and timely analytics to assess the infrastructure. Again, similar benefits, improve the safety, reduce the costs, and increase the reliability. Another very important topic to utility infrastructure providers is the management and the risk mitigation from vegetation encroachment. Yeah, and it's also to reduce potential clearance violations. Vegetation is the leading cause of power outages that impact the system reliability, as well as the safety of the public and of the staff. And vegetation management makes typically the largest portion of the annual maintenance costs for TNDs. Here, analysis of remote sensing data, lidar data in particular, this allows to automatically identify areas where encroachment, where potential encroachment is happening on the ground along conductors, also the pole top, yeah, and to identify potential clearance violations with nearby structures. Yeah, there's also a huge potential in the use of SAR data, synthetic aperture radar data, so data taken from the space, from a SAR satellite, from a radar satellite. And this allows to monitor land displacements, which is also of interest along utility infrastructures. Subsidence in many cases is not only a consequence of tectonic activities, but also of human activities. Thinking of extraction of groundwater, mining activities, and so on. And even a few millimeters per year can be dangerous to the stability of building infrastructure or pipelines, or they can trigger landslide events. Traditional methods are also difficult, expensive, and it's particularly difficult to permanently monitor very small terrain displacements with a high accuracy and a dense spatial coverage. Here, using SAR and in particular so-called interferometric techniques, so particular techniques applied to radar data from space. By using that, land displacements and deformation maps can be derived from SAR data to monitor in particular linear infrastructures, such as, for example, pipelines which are under pressure. And this can happen. This is based on large multi-temporal observations with accuracies of a few millimeters if you use a so-called persistent scatter approach. Again, with the benefit against traditional techniques, so thinking here of GPS and leveling and so on, that it's a remote data capture. We need no local hardware, high density of information, wide area cover, along with a high precision and accuracy. And yeah, maybe, you know, with SAR, with Sentinel-1, that's one of the typical SAR satellites used for such applications. We have a temporal resolution nowadays of about 1 week, and this can be improved with other sensors. It might be improved with small sat launches in the near future, with the goal to highlight areas where land is moving. Yeah, having now just shown you some examples, some real-world use cases where remote sensing data combined with analytics can help to optimize costs, increase the efficiency and improve the safety, in particular for asset management operations. I would now like to present you what we at L3 Harris can offer you to that regard. Yeah, and as James already introduced, leveraging our years of success in defense and intelligence domain, we have now commercialized our advanced data management systems for utilities, and we call that product Amplify. Amplify is our end-to-end centralized asset data management solution, which is used in utilities. It collects, manages, and leverages all type of remote sensing data with the goal to manage and to analyze network asset infrastructure. Asset management, which is one component of Amplify, this includes the inventory, inspection, change detection, monitoring of the current state of infrastructure. And this product Amplify can seamlessly work, and you will see examples of that, with other operational systems typically in place, such as a GIS, a work management system, or an asset management system. With Amplify, we take advantage of our core competency in processing, storing, discovering, and exploitation of geospatial data at scale. And with this technology, we are able to ingest imagery, but also other type of remote sensing data, lidar data, videos, to analyze the infrastructure. With Amplify, users in the field or also on an operation data center can quickly locate the intelligence using discovery and filtering techniques to make decisions. Examples here include our deep learning capabilities to detect, for instance, anomalies on the sets, such as damaged components or corrosion. Also vegetation management and clearance information, which is typically based on lidar data. And then in particular also change detection, for example, after a disaster, or by leveraging historical data that is managed by that system as well. So change detection, this can be used for any time period for proactive insights on the changes that are occurring on the network. Thinking here of increasing pole type with time or changes in joint use attachments and so on, developing rust at components. So Amplify is a system that can deploy any number of analytics, in particular, of course, our analytics, image classification, also multi-hyperspectral analytics, and these are brought together and Amplify in the form of utility-specific workflows that allow to take advantage of all the power we can offer in terms of analytics without requiring on your side to have a staff of image scientists. So again, important to highlight, Amplify provides capabilities for both data management and discovery, in particular for huge data volumes. We speak in terms of images, we have a big data problem. And on that, it can run automated processing on both new collects that you have collected and on archive data. And in this way, Amplify can extract additional value from the existing and of course also expensive collects that T&D companies have already invested in. So here you see a screenshot from the Amplify-Map View with a cartographic visualization in the back. Well, here it's a satellite image, and it is showing detected damages at power poles with icons. So red icon means an alert. Yellow icon means a warning, and the green icon means normal condition. So no anomaly has been found. So speaking here about detected damages, as well as icons you can see here on vegetation encroachment. And if you click on that icon, the remote sensing data from that information has been extracted, can be accessed for further investigation. Description, coordinates, and also screenshot on image of the damage, speaking here of damages at power poles, or whatever output results comes from the analytics, in the form of a report is typically the final output that is needed. For instance, to generate work orders, such as for subcontractors, to cut back vegetation or replace damaged components. The report is also generated by Amplify, which provides the answers and insights that are finally needed to remediate the damage and get back to normal condition. Yeah, the unique positioning of our commercial off-the-shelf products at L3 Harris and the analytics that we have in these products, this allows us to extract the maximum value out from the data that we incorporated in Amplify. You may know our product ENVI. ENVI can be considered as the leading optical image platform analysis software to extract information from remote sensing data. That is providing analysis tools for satellite, airborne, UAV platforms, from hyperspectral, multispectral sensors, lidar, elevation data, and with its module Starscape also for radar data. We also have analytical capabilities on lidar data for classification on trees, power lines, poles, and buildings. And we develop our own machine learning technology that includes state-of-the-art deep learning, particularly designed to solve geospatial problems. So by incorporating Amplify a combination of the advanced analytics that we already have in place in ENVI and that are long used, that we have in Checkwire for data management and that are used for decades in the defense intelligence domain, and with our deep learning technologies offer, we have the ability to evaluate set conditions and to provide answers, particularly through lidar analytics. I've spoken about vegetation encroachment. So Amplify can support a vegetation management workflow, and it automatically identified areas of encroachment. And the output from this analysis provides areas, for example, field crews to remediate the encroachment. Also clearance analysis, as well as identifying potential clearance violations with nearby structures. From lidar data, we can also identify pole tilt angles, set alerts, or also from terrain analysis, determine if a pole is accessible from the nearest road. Yeah, and as I mentioned, we leverage our deep learning technology and apply that to imagery for both the asset identification and location, and to detect asset anomalies and defects. And here you see some examples of that. Deep learning itself can often derive better results compared to traditional classification approaches. And deep learning is well suited to extract features from a complex background, regardless of their shape, color, size, or other attributes. So while deep learning is particularly suited for operational applications, with the main objective to detect representations in images, and it can do that at very high accuracies. So speaking here of accuracies of better than 95%. It means on the other side that we need labeled training data, and that must be generated, but that can also happen synthetically. Our deep learning technology is used by utility companies as a dependable and cost-effective solution for the inspections. And for example, here, and these are figures from a recent customer engagement, we deployed that deep learning technology to identify specific assets on distribution poles. Also to locate poles and insulators, as well as to identify anomalies. And such anomalies, as you can see here, they can range from missing or damaged components, pole, split, rod, also detecting birds' nests or other animal infestation, lightning strikes, corrosion or rust. And as you can see in the main figure here on the lower left, that's detected contamination, flash, and broken, missing conductors. Yeah, what is the workflow? How does Amplify work? Well, we typically first need the data. We need to collect the data and we need to ingest the data in the system. And then based on the data, we run the analytics. We need to process it to get analytic ready data and then analyze it in order to generate the answers, insights, and reports that allow to disseminate and act. Yeah, as mentioned, the collected data, and this can be data from all type of acquisition platforms, UAVs, helicopters, satellite, terrestrial. And this can be data from all type of modality as well, optical, so RGB, infrared, hyperspectral, multispectral, lidar data, SAR data, and so on. And this data is uploaded in the content management system, one of the components of Amplify. And yeah, it's also possible to subscribe for satellite-based web monitoring services in order to take advantage of satellite data as well. Yeah, and this data, once it is uploaded in the system, it is first, of course, it needs to be managed, and the one element of Amplify is the data management systems, so storing, cataloging, also offering capabilities to search and discover that huge amount of data, archive data, and of course new data that was just ingested in the system. And based on that data, we run analytics. This can be deep learning analytics, as mentioned before, for asset identification, location improvement, updating the inventory, damage inspection, and anomaly detection, and particularly based on lidar data, the vegetation encroachment. Yeah, and satellite monitoring services, so meaning satellite data is used at a regular base, but typically higher temporal resolutions, and processing is running in the back. I will show you examples on how radar data is used on land displacement monitoring, and it's also possible to use optical satellite data for monitoring vegetation at a macro scale, it must be said. Yeah, and this then allows to act on the side of asset management and planning operations, infrastructure mapping, remote inspections and change detection, manage vegetation encroachment, and mitigating risks, of course, doing this clearance analysis, using, for example, also hyperspectral data to predictive growth, yeah, and responding to weather events. Damage assessment is in several countries also an important topic to understand what happened after an event, to quickly yeah, restore the assets. Yeah, and let me now show you a short movie with a demo of Amplify. I hope it runs smooth through GoToWebinar. So you should now see the video. I will now start it. As a first step, you see here the upload capabilities, where new collects of data can be uploaded. Video is a little bit quick. We are now in the catalog view. So in this catalog view, we can find damages that have been found in the system. Here's the map view. We can zoom in. We have here a visualization of the damages that have been detected. Again, in red are alerts, so an anomaly has been found. In green, normal conditions, and if we click on these icons, on one of these icons, we see the images. Based on that, the analytics have been run. So here, for example, the deep learning analytics found pin insulators, here in green, and a transformer. This is collected from UAV data, from very high resolution UAV data. And again, deep learning is running in the back to find these components. Of course, there are models in the back that have been trained to find such components. Yeah, now let's have a look when alert has been detected. Here an insulator is broken. You see here where the deep learning analytics in the back automatically identified that damage. Insulator is broken, and also normal conditions that have been evaluated. No insulators flashed, no bird's nest, and it can be accessed from the road. Here another example, an insulator's flashed. And what you can see here quite well, where there is an obvious damage that has not been found by deep learning. And yeah, it must be said, deep learning is an iterative process. It takes a time to get a rigorous model, and depending on the approach and how we work together with customers, it's of course possible to improve the deep learning model within Amplify by adding that damage to the system, and the model will be retrained to improve the results. Yeah, lidar data is another type of data that's ingested. In Amplify, we have a lidar viewer included, and of course analytics that are running on it. Here you see that yellow cylinder and some red dots. This is vegetation that is encroaching into a clearance within 10 feet. This is 3 meters within the pole. This has been detected, and it has been also detected that it's difficult to access the pole from the road. And again, you see here normal conditions. So we also do some terrain analytics in order to understand for teams that are in the field how easily they can access these poles. Is a road nearby? Here we have a profile of the terrain. You see some steep slope here. Set this for customer in the US. A link to Google Earth, of course, something helpful here as well. And yeah, we see there's a steep slope to access this power pole. Yeah, image view, lidar view, and it's depending on the modality what data is collected and which analytics are run. Again, here on the image data, deep learning found that one avian cover is missing, so that one insulator is not detected. So the blue means, and you see that in the image, there are 2 avian covers, but in the middle, an avian cover is missing. Okay. Yeah. Now extending the capabilities in Amplify to what can be done, could be done with satellite data, optical data, SAR data. And here the continuous, using optical satellite data and continuous analytics, automated monitoring, particularly on vegetation, as it is based here on Sentinel-2, this can be a promising and cost-effective approach for optimizing preventive maintenance over long sections of linear infrastructures, such as also for rail and utility corridors or along oil and gas pipelines. Analyzing satellite imagery, even at a low resolution as we have it here, again, Sentinel-2, 10-meter spectral resolution, somewhat similar to Landsat. But it can help to determine at which areas to have a closer look for more detailed in situ investigations later. There are also commercial, very high resolution satellite imagery available that, however, needs to be purchased. So that's not free of charge. It can go up to 30 centimeters. But here, this example is based on freely available Sentinel-2 images collected about every 6 days in Central Europe at 10-meter spatial resolution. Yeah, and since the data is free and since the data is captured regularly, this allows to run automated services in the back, such as the vegetation hazard workflow that we have created here. And this is continually running and monitoring vegetation at a macro scale. And then it sends alerts when a region indicates results of concern due to the identified potential of vegetation hazard. Yeah, the use of free satellite imagery will probably never get to the level of resolution needed for most of these inspections. But again, what it does allow is companies to quickly take a first pass of an area at a macro scale and then plan flights and to have closer looks in certain areas. Yeah, when speaking about automated monitoring, of course, with optical, we have problems of clouds and weather conditions. We don't have that with radar. So when we would like to set in place operational monitoring services using satellite data, SAR, so meaning radar, is the most promising approach because it is independent of weather conditions, collects at day and night and under cloudy situations. And we also already had a first slide of that. We spoke about interferometric techniques. And in ENVI SARscape, our commercial product, to analyze SAR data, and the analytics are or can be incorporated in other platforms, including Amplify. We can apply interferometric techniques to determine land displacements, deformation maps from SAR data. And this can be of particular interest when also monitoring critical infrastructures. This can be point infrastructures if you want, such as dams, transformation stations, switch gears, or as it is the case here, a nuclear power plant in Hungary. So this study is based on freely available Sentinel-1 time series data. Sentinel-1 is the SAR satellite of the European Union Copernicus mission. Before we spoke about Sentinel-2, that's the optical satellite. In the study, as you see here, has been conducted by our partner sarmap in Switzerland. sarmap are our partners and developers behind the ENVI SARscape analytics. Here in this figure, you see a map, a deformation map at the millimeter scale. Let me see if that works. At the millimeter scale, plus minus 5 millimeters, and this is also the accuracy that you can get in that term. Yeah, and we're now looking at that specific location of the power plant. The results here indicate vertical land movements, a slight uplift at the power plant of about 1.5 centimeters over 4 years. Yeah, and this is run with a so-called intensities time series workflows that is incorporated in SARscape that can be executed on a processing sequence of multi-temporal stacks of SAR images. So you get that accuracy if you use stacks, multi-temporal stacks of SAR data over long time spans. You see a certain noise here in order to detect and extract that spatial temporal changes. Yeah, the second study that you can see here is also on land displacement deformation using SAR informatic techniques, and it's also based on the Sentinel-1 data. And it has also been conducted by our partner sarmap in Switzerland, but here not on a point target, but on linear infrastructures. So the area you're looking at here is Tuscany, central part of Italy, a particularly hilly area. And our customer here is a water pipeline operator, and the area is also affected by a certain number of known landslides. So the problem, as we had it before, is to identify the interaction between known landslides and pipelines, known meaning identified by SAR techniques. Yeah, and the use case is also clear. It's the risk around the infrastructure. Yeah, just for that example, SARmap used Sentinel-1 freely available data. Again, a revisit time of 6 days. So every 6 days, images are captured. 2 different data sets need to be processed, must be set. There's an ascending path, so meaning it flies from the south to the north, and a descending path, meaning it flies from the north to the south, in order to really get that vertical displacement. And over 300 scenes over 4 years have been assessed here. Yeah, and what we are looking at here are the output results as in the upper image. This is the horizontal velocity in millimeter per year over time. So it's the velocity component along the east-west direction, meaning in slant range. This technique, by the way, does not allow to find movements in north-south direction, which is the azimuth direction, so the flight path of the satellite. Yeah, the red line here corresponds to the layout of the water network. The red color in the back, these are positive values. This corresponds to an eastward shift, so east direction is characterized by positive values, whereas the blue color, negative values, corresponds to a westward shift. And the slope of the hill slopes, these confirmed the measurements that are made. An active landslide event in the center of the image is very clear. Yeah, and here in the middle, the area in the middle that overlaps with critical infrastructure, which is here, that might put at risk. And that can be seen that both sides are sliding in agreement with the inclination of the ground. So on the right, blue color, the slope is inclined to the west. To the left, red color, the slope is inclined to the east. So again, here, an active landslide event, water pipelines under pressure, this might be put at risk. Yeah, in the below image that shows the average vertical speed displacement, also in millimeter per year. This is the vertical direction, the vertical velocity component. So upwards, if you want, here we had east-west in that direction. Again, red color, positive values, displacement upwards. But in this case, this was not detected. You see mostly blue colors, negative values. This corresponds to downward shift. So meaning subsidence, meaning the terrain is going downwards. Yeah, and when we combine the results obtained from the two processing stacks, we can recreate the movement in east-west direction and up-down to evaluate potential risks here on pipelines. Yeah, speaking about data, satellite data in particular, MapMart, which belongs to L3Harris, founded in 1995, has a long legacy in selling data, and today we offer the largest selection of geospatial products worldwide, and this includes satellite imagery, aerial maps, digital elevation models, vector and lidar data. For satellite imagery, for instance, we partnered with leading satellite image providers, including Airbus, Digital Globe, and Planet, to offer data and information for any location in the world. We also sell elevation data. We offer a wide variety of in-house elevation data sets and partnered with leading providers also such as Airbus, also Intermap, to provide high-resolution DMs. We also offer satellite image services, so we provide a wide range of high-quality professionals and custom satellite mapping services, really providing end-to-end capability from data acquisition to data processing to data analysis. Yeah, and utilities, there are quite a lot of applications, particularly for the use of elevation data, for example, in terms of electricity, power plant construction estimation, cable route selection, plant facility site extension. Particularly in terms of telecommunication, we currently sell a lot of elevation data for radio propagation simulation and antenna location analysis. The particular application is here to the 5G Internet of Things market. There are also road, railways, route selection, land work estimation, airport, harbor, disaster mitigation. There are a lot of examples where we again sell data and offer geospatial services. Yeah, we have now provided you with a quick introduction to the utility offerings at L3Harris, including data, including Amplify, and also how our ENVI and SARscape analytics are used in Amplify to leverage the power of imagery. And before we now finish, let me conclude and let me first show you how Amplify integrates with utility operations ecosystems that are in place. Yeah, we here understand the requirements around operations, the integration, and we have developed Amplify to work seamlessly with other operational systems, including GIS, work management, and asset management. Yeah, and with Amplify, we deliver an end-to-end solution that can plug and play in any of these offerings seamlessly into an existing system. Maybe particularly speaking about GIS, not to confuse, we don't want to compete with a GIS, or we don't even want to replicate a GIS. You saw that Amplify is somewhat different. It focuses on images, data management of images, and analytics of images. But we want to integrate Amplify in existing data management system, such as it is represented in that figure. And then the GIS integration can be used. First, that results can be exported from Amplify to update an existing GIS system with the information derived from our analytics, or the data from a GIS can be used support for mission planning by accessing the GIS data representing in the infrastructures, such as layers to answer questions, proximity to water, archaeological voids, and so on. Yeah, Amplify can integrate with work management systems, to integrate with ticketing systems to create work orders when anomalies are detected. Yeah, and with asset management to integrate with maintenance management systems to compare analytic results with historical inspections and repair records, change detection. And looking forward, we can the analytics in Amplify can provide an accurate asset database to detect components and knowledge about components of an asset. This is particularly important for predictive modeling and lifecycle simulations. Yeah, and compare current asset configurations as detected by the analytics with as designed specifications or as built records. Yeah, let me now conclude with the statement that there's a significant potential in using remotely sensed data combined with analytics, with automated analytics, for the utility asset management operations, with the key benefits in optimizing costs, improve safety, and ensure reliability and customer satisfaction. And with Amplify, we offer an end-to-end centralized advanced asset data management solution for utilities, and this includes data management and automated processing in order to provide the answers that are needed in operative asset management. Maybe speaking a little bit more at the end about the key development themes and applications in Amplify. Again, important is the data management component. Amplify creates a centralized shared repository for imagery, lidar, associated data, and other type of remotely sensed data. And it allows users to attach, edit, replace, remove documents, reports. One of the key applications in terms of analytics is to locate and identify infrastructure, identify assets on the pole, material identification, and we incorporate deep learning tools to improve outcomes, particularly for identifying and capturing damage. This can be also damages from overheating equipment, from thermal data, corona effects if such data is captured, in order to generate inspection reports, work orders, and to improve the preparation time and efficiency in making repairs. Managing vegetation encroachment is an important topic. Particularly with LiDAR data, Amplify can measure the clearance in order to reduce fees for non-compliance. It can also identify pole tilt angles to set alerts, determine if a pole is accessible from the nearest road. What is also possible with hyperspectral data is species identification, understand what type of vegetation is on the ground. That is then also depending on specific growth rates. And another key application is to identify wildfire risk near utility infrastructure to better predict and at the end mitigate for asset-induced fires. Monitoring change, track asset conditions over time to predict repairs needed before the failure, and to run automated processing on both archive data and new collects to extract additional value from data that has been taken already, to monitor and to observe what has been changed, which can also lead to post-storm damage assessment, change detection analytics to detect anomalies between a baseline and data that might have been collected immediately after storm event for automated post-storm damage identification to better position repair crews. Yeah, thank you now for attending. And here are our contact details. We would now be happy to answer your questions. And I hope there are a lot of questions, but looking at the time, it's 10 before 12, my local time in Europe. So just to mention, regarding the short time we have remaining, we may not be able to answer all of your questions today, but either we or colleagues of us would be happy to connect with you individually after the webinar in case you have questions. So so let's have a look at the first questions, and I give the word back to James. So
that's wonderful. Thank you, Nikolai, for a really excellent presentation. So at this point, we'll get to some of the questions that have come in through the webinar today. As a reminder, you can send us a question by using the questions chat box on the GoToWebinar dashboard. We'll try to get through as many of these as possible. The first question I'll answer quickly. It's about getting hold of the slides and the recording from the webinar. So look out for an email in the days after this webinar. This should point you towards these resources. So we'll get to the first question. A lot of these questions that I've been looking through actually are about really how to make real this technology within your organization, how to employ remotely sensed data to meaningfully answer the questions of asset management and infrastructure monitoring. So the first one, maybe Nikolai, if I'll read the question as it's arrived, and if you can answer it, that'll be helpful. The first question, I understood Amplify is a new commercial product for utilities, including data management and automated analytics on both the archive and new collects. Is this correct? And do you also help to collect the data?
Yeah. Okay. Well, regarding the Amplify product, you are correct. So Amplify is an end-to-end solution for asset data management, a solution particularly designed for utilities, and it's including both data management and automated processing. In order to provide the answers that are needed in operative asset management. You saw in one of the slides that we also sell satellite imagery, aerial imagery, in particular digital elevation data, and so on. And I mentioned the example that in utilities there's currently high demand in high resolution elevation data, and here we sell the it's called AW3D elevation data. It's from Restec in Japan, which is really highly accurate EM with high resolutions for planning that telecommunication mobile networks for that new 5G standard. But yeah, we at Harris, however, we do not directly act as a service provider. So we are not flying with helicopters or UAVs to collect the data, but we can, and we do work together with partners here, with different partners, so that at the end, what we can offer at the end is Amplify as a product itself, or to you as a transmission service operator, distribution service operator, or any other utility service operator, such as a pipeline operator, or it's also in the field of highways or railroad network operators, or any other type of customers. So we sell this technology, it's a commercial product, and if this is required, we can also offer an entire package together with partners, which can then include the data capturing as well. So I hope this does answer the question.
Okay, thank you, Nikolai. So we'll move to our next question, which is about running lidar collect. So question reads, I use a third party to fly image and lidar collects and run analytics on T&D infrastructure. My data volumes are often huge, and I feel I may be missing insight. All I see is a report. Can Amplify help?
Okay, well, the report is typically the answer and the insight that is finally needed at the very end. To generate work orders. Amplify itself, however, as you saw maybe in the demo, can give you much more insights. For instance, there's also that map view with that cartographic visualization. You saw that detected damages on poles and also the vegetation encroachment component from the lidar data. We can also show in Amplify the output from the analytics directly from the data. So showing the data itself, from that the information has been extracted, and the analytic itself. So is it the vegetation encroachment? Is it a specific type of damage or an identified asset? So you can check in the data itself as well. And yeah, Amplify at the end is architecture to incorporate any of our analytics that we offering. And if you know our commercial products, ENVI, SARscape, and so on, you know the vast capability of analytics we have, image classification, in particular the spectral, hyperspectral analysis and lidar feature extraction and so on. This could also incorporate the satellite-based monitoring services. You saw that example on SAR-based land displacement. Yeah, and also remember that Amplify is not only on the analytics side, but also on the data management side. So it's not only the report you get, it's the visualization of the data, of the damages, and it's all that component of managing the vast amount of data in a centralized data management system. again, with Amplify, it's data management and discovery of huge data volumes, and it's analytics, not only on the new data, but also on archive data, really monitoring change. And yeah, again, in that way, we can offer much more value as a simple report at the end. The particular value is also that you can work with the data, you can have the data on your side, and you can see what's changing over time to really leverage information of the data you have already invested in the past. Yeah, that's what I would say. Wow.
Great. Okay, thanks. And I think probably we have lots more questions, but maybe we'll take one more now and then we'll close. So our final question is going to be well, it's a slightly different question. It's perhaps focused on oil and gas rather than utilities. It's about pipeline monitoring. So the question reads, pipeline subsidence is a big problem made worse through accelerated mismanagement of groundwater. So question I expect from the Middle East. I understand that SAR, synthetic aperture radar, could provide a solution, but I'm new to the technology. What recommendations can you make to get started?
Yeah, well, talk to us. I would suggest, as I would suggest in many, in many opportunities, to arrange a web meeting with us as soon as possible. And in that web meeting, we can discuss and learn more about your needs and requirements, so that we can then better understand and evaluate how Amplify and our offers can be most helpful. Yeah, with ENVI SaaScape, so the analytics that you saw, we are selling commercial software products, a commercial software product that of course includes that SAR and different capabilities as well to generate just such land displacement and deformation maps. But yeah, as you mentioned, depending on your needs, and you mentioned you're new to the technology, so understand that you maybe do not want to establish your own in-house expertise in SAR, which then also means typically to build up a proof of experts. We of course can help, and particularly together with our partner sarmap, to deliver whatever insight and final output product you need. Also in the form of web service if this is needed. And yeah, as mentioned in the webinar, our solutions and utilities do not stop at offering the technology, but it really ranges from the data collection to data storage to asset management, processing and analyzing data, and at the end to deliver the answer, the insight that is needed for your needs to resolve your problems.
Okay, that's great. So I think we'll probably draw the session to a close at this point. I wanted to say thank you to Nikolai for a really excellent presentation. Thanks to our audience also, we appreciate everyone's attention. If we didn't get to your question in this case today, then feel free to drop me a note, drop Nikolai a note. Our contacts are on your screen now. Thank you everyone, and have a great rest of the day.
Thank you all for attending. Thank you, James.
Okay, goodbye.
Goodbye.